Hello students, good morning. The next topic is dual nature of matter and radiation for KSET, NEET and JEE purpose. It is a small topic, but it includes photoelectric effect also. In this energy of the photon is a packet of energy for the radiations like electromagnetic waves. We have already discussed all the electromagnetic waves possess the energy and transmit the energy in the form of the waves containing the electric and magnetic fields. The energy for the n number of photons, photon is a packet of energy, h is a Planck's constant given by the Planck quantum theory, that energy of the photons of the frequency f and with number of photons n is E equal to nhf, or E is proportional to n, E is proportional to f. More frequency, more energy, more number of photons means more intensity, more number of waves indicates more energy. And C is equals to f lambda. If substitute, you can get the expression f is equals to c by lambda. This formula also can be written as nhc by lambda. C is the speed of light in vacuum, which is 3 × 10⁻⁸ meter per second. But Einstein's mass relation is E equal to mc square relation. We have from this we get the equivalent mass and equivalent momentum. That point term is important. It is not mass of the photon. You have to call it as a equivalent mass of the photon. Photons don't have actually mass. But when they are traveling in the vacuum, they travel like a wave only. But when they interact with the matter, falling on the electron, falling on the any materials, then they behave as if they don't have. They behave as if they have the mass equal to mc square. So this m becomes equal to E by c square, this term. So that is called as equivalent mass. The photon behaves as if they have a mass, equivalent value m equal to E by c square. C is the speed of the light. And equivalent momentum, c square can be written as c into c. Once you go to the left side, becomes equal to mc. Mc is the momentum, is mass into speed. Here velocity, or velocity of light, or speed of light. Mass into velocity is nothing but equal to E by c. Wherever E is there, you can replace that E with nhf or nhc by lambda. If you take n equal to 1, n equal to number of photons, if n is equals to 1, that is for 1 photon. If you take 1 equal to 1 photons means they don't mention this n value in the expression, then this becomes equal to hc by lambda by c, c cancels h by lambda. The momentum we take represented with the symbol p, the p is nothing but equal to h by lambda. More lambda means less frequency. Less frequency indicates less momentum, that you have to check up the relationship. Next is power. Power of the radiation is nothing but equal to energy by any of these expressions you can represent for the calculation of the powers. By t is the time here. And rest mass of the photon, in case if you stop the light, if the photons are stopped, there is no speed. No speed means no mass is considered. Rest mass of the photon is taken as a 0. Don't substitute c equal to 0 for that, you will get infinity, but not that condition. We will take this photons. Photons not in move means there is no question of the consideration of its mass only. Photon is the energy packet which is always in transit, just like the heat. It is the energy which is always in transit, means always try to travel. And while traveling only means speed is there only, we will calculate the mass, equivalent mass and equivalent momentum. So whenever the photons are falling any matter like electrons, when photons falls, the electrons will be ejected from the surface of the materials. That is called as the photoelectric effect. In this case, the photons which are having the energy only, having the electric and magnetic fields, and eject the electrons. Electrons are the particles having the mass, but energy, it is energy waves only. Photons are nothing but energy waves. Energy waves are able to move the particles, means only particle can hit the particles. That means this energy behaving like a particle, having the momentum is equals to h by lambda. And whenever it hits the electrons, the momentum is exchanged, just like the elastic collision. Momentum is exchanged with the photons and electrons are ejected out of the surface. This is called as a photoelectric effect. We will discuss again at the end of this topic. Next, these photons having the dual nature was known already, and de Broglie used that assumption. If the photons have the dual nature means double nature, having the wave nature and interacting with the matter having the particle natures, then the particles also might be having the dual nature, and that is called as a matter waves. Metal having the wave nature is called as a matter waves. Mass particle, generally we take the stone and throw it, it travels in straight line path, but according to the de Broglie, the particles do not travel in straight line path, but they travel like waves. If wave is there means it has a length called as a wavelength. Here it is not the question of the particle producing the waves. Whenever the charged particles having the oscillations or motions accelerated, they produce the waves called as electromagnetic waves. But here we are not talking about the radiation of the waves or produced waves. We are talking about the particle traveling like a wave. Wave itself travels like a the particle itself travels like a wave when not interacting with the other materials, other particles. But whenever it hits with other particles, it behaves like a material or matter. That means the particles have the dual nature, the matter nature and wave nature and particle natures. That's called as the dual natures. Specifically observed is for the small particles like electrons, protons, neutrons, even the atoms. Next is de Broglie wavelength. The de Broglie wavelength is given by the formula, same relationship, lambda is equals to momentum is equals to h by lambda. So lambda is equal to h by momentum used for these particles. So lambda is nothing but equal to h by mv. Mv is nothing but equal to p. That is the momentum equal to mass into velocity. Lambda is equals to h by mv, but kinetic energy and momentum relation is kinetic energy, you can take Ke or E is equals to p square by 2m. P is a linear momentum, so P equal to 2m into kinetic energy. But if you check the charged particles, they can be accelerated with their voltage V0. Then same kinetic energy can be written as charge into potential difference V0. Is the word done? In terms of the potential difference V0. Kinetic energy is also equal to half mv square. Careful with the symbols of V. Capital letters generally given for the potentials, small letter for the velocities. Is to avoid the confusion, I am writing V0 for the voltages. So here this momentum P equal to 2m into kinetic energy, 2m into kinetic energy. And kinetic energy can be further replaced with Q into V0, Q into V0. This is for the charged particles. V0 is exerting voltage, and if it is not charged particles, for the F equal to 3 is degrees of freedom. For the particles which are moving under the effect of temperature, this K is a Boltzmann constant. The kinetic energy expression for the gas, kinetic theory of gases formula, you will get kinetic energy equal to under root of 3 by 2 kT for each particles. And this 3 actually is degrees of freedom. For monatomic gas, if you are taken like single particles are present in the gases, like monatomic gases, helium, neon, argon, etc., that inert gases, monatomic gases, if they have, for them degrees of freedom is 3. And if you have the diatomic gases, degrees of freedom is 3 translational and 3 rotational, total 5 will be there. So this will be different for diatomic gases. But we are talking about the neutrons here. Neutrons are the single particles, so their degrees of freedom is 3. Means they can go along the x-axis, y-axis or z-axis. 3 degrees of freedom we have, depending on the temperature. So kinetic energy is proportional to root of T. Wherever this kinetic energy expression is for the charged particles, replace with the QV0 for the particles which don't have a charge but are accelerated with the help of the temperature, wherever E is there, replaced with the energy with 3 by 2 kT. Sorry, this what is not there, just energy or substitute. Next is for substitution of this charge and mass, H and H Planck's constants. These are the constants for the given particles. Mass of the electron, if you take the electron, mass of the electron, charge of the electron, and Planck's constant is fixed values. Only in terms of the voltage variable, if you take the lambda for the electron is given by 12.27 by root of V0 in angstrom units. Angstrom units. 1 angstrom is nothing but equal to 1 angstrom equal to 10 to the power of minus 10 meters. And 1 nanometers is nothing but 10 to the power of minus 9 meters. It may be mentioned in terms of the angstroms, or it may be given in terms of the nanometers. Careful with the terms. Next is protons. I am giving in terms of the angstroms. If you take in terms of the for the proton, 0.101 by root of V0 angstroms, but generally they will ask is for the electrons. For other particles they will ask the ratios. Ratios for the proton and deuteron or alpha particles, they may ask. Charges and mass are different for these particles, that you check up in the notes. You don't have to remember the remaining formulas. Your electron you must remember, and proton not required. But neutron you must remember again formula, as lambda is inversely proportional to absolute to temperatures. Wherever energy is there, we are taking 3 by 2 kT. 2 cancels, what you get is 3m into kT. M is the mass of the particles. If it is not a neutron, you may be given gas particle mass, and Boltzmann constant is a constant value. There is no need to bother about it. So relation will get in terms of the temperature. Lambda is inversely proportional to root of T. T is absolute temperature, means temperature in Kelvin scale you take it. It is absolute temperature. Next is orbiting electron. If electrons are revolving around the nucleus, they don't move in a straightened path, but they move in the form of the waves. Then according to the Bohr's postulate, second postulate, only specific orbits are possible where the angular momentum mvr is equals to nh by 2 pi. N is principal quantum number or orbital number. N is equals to 1, 2, 3, 4. You cannot have the 1.5, 2.5 like that. Fraction value is not permitted. Then why specific values are only permitted was not given by the Bohr's, but can be explained in terms of the Bohr's, de Broglie's hypothesis. According to that, the electrons are not traveling the straight line path, they move in the form of the waves. So only particular waves where the wavelength can be fit into this orbit is only permitted. If it is not able to fit in the orbit, it cannot be permitted. Means the number of wavelengths. You have to consider that circumference. Circumference is nothing but equal to 2 pi r. R is the radius of this circular orbit. 2 pi r equal to n lambda. Lambda is nothing but de Broglie wavelength of these electrons. Whenever this n equal to 1 times lambda is 2 pi r, then this r is permitted. Otherwise, it is not at all permitted. N is the orbit numbers. And electron microscope. Electron microscope works on the principle of the dual nature of the electrons, which are the matter waves, means wave nature of the electrons. The electron's velocity, if it increases, velocity can be increased by increasing the potential difference, accelerating potential difference. More velocity, less lambda. Less lambda, then better scattering you can notice. Then electrons are scattered from the material. Any metal particles are there, the light wave scatters, diffraction pattern takes place. The interference pattern can be again observed after diffraction for these electrons. And you can see high resolving, high magnifying power microscope. You can see the micros more clearly with the help of this electron microscope. And the resolving power of electron microscope is directly proportional to root of V0. Generally, they'll ask is the ratio of these resolving powers. Inversely proportional to lambda and directly proportional to V0. Next, the scientist who worked on this dual nature of the electrons is Davison-Germer experiment. And G.P. Thomson. G.P. Thomson is the son of J.J. Thomson. J.J. Thomson discovered electrons. His son G.P. Thomson did the experiment, and these two people, scientists, proved that electrons have the dual nature. Next, we need to work out some problems linked to this topic. Next point, problems. Conversion of this energy in terms calculation of the energy for the wavelengths, we can take a energy equal to hc by lambda, substitute of this h and c and lambda in angstroms. Direct formula for this energy calculation is 12400 by lambda in angstroms, energy in electron volts we can take. Next, problems. Electrons have energy 10 kilo electron volts given. Find the de Broglie wavelength, third question please, of electrons. Electron lambda is 12.27 by root of V0 voltage in angstroms. But what you are given is the energy is given in 10 kilo electron volts. 10 kilo, kilo means 10 to the power of 3 electron volts. 10 to the power of 3 into 10 is 10 to the power of 4 electron volts. This is nothing but 10 to the power of 4 electron volts. And 1 volt potential difference provides the energy of 1 electron volts. 10 volts means 10 electron volts. Electron volt is the energy gained by the electron when it passes through the potential difference of 1 volt. So 1 volt provides the energy 1 electron volts. 2 volts means 2 electron volts. So directly electron volts convert into volts, because in the expression we require accelerating voltage V0. So energy is 10 kiloelectron volts means 10 to the power of 4 electron volts. That V0 is 10 to the power of 4 volt we will get. So V0 is 10 to the power of 4 volts. Root of 10 to the power of 4 is 10 to the power of 2 means 100. 12.27 by 100 is 0.1227 angstrom units. This is the answer for the de Broglie wavelength of electrons. Next question is, electron at rest is accelerated. At rest, initial velocity u is 0. Is accelerated by electric fields E. Uniform electric field E, that is a constant given in the question. Find the rate of change of, you are finding here not just wavelength please, you are finding the rate of change of de Broglie wavelength with the time t. Lambda is not constant, it is changing with time, that you have to calculate. Acceleration of the electron in the electric field, formula for the electron charges. Charged particle moving in the electric field have the acceleration A equal to QE by M. Minus sign actually will get, minus indicates for the electron is, it is accelerated opposite electric field. If you take the capacitor plates, 2 parallel plates if you have taken, and connect to the battery potential difference V, separation is D, E equal to V by D. That may be, this same question can be asked indirectly in terms of the separation of the plates D and potential difference V. E equal to V by D. Electric field is produced between the two plates, and electron kept between the plates accelerate opposite electric field and moves in this direction. Acceleration means what? Velocity is not constant, it is starting with the velocity u equal to 0 and going forward directions, opposite electric field. So formula part we have is final velocity kinematic equation V equal to U plus AT. U is 0 starting from rest, so V becomes equal to AT only. That means E by M. I am taking only magnitude here, don't take the negative sign. Negative sign for this acceleration indicates only upward direction, but that is not bother for us. We are not going to take that relation, not required here, unless direction is important. So acceleration is E by M into time is a velocity. So d Broglie wavelength lambda is equals to, we have h by mv. V is not constant here. V is first is u, afterwards v. As the time increases, velocity changes. Therefore, this velocity changes means lambda is also not constant. If the v increases, lambda keeps on decreasing. So initial lambda is larger, velocity is less. As the velocity increases, the lambda goes on decreasing, compresses. So we have to calculate this expression for the rate of change of lambda. What is the lambda expression in terms of t? Lambda is equals to h by mv. V substitute from here. V substitution, V equal to E by M into T. So we will get as M into V. M into V is E by M into T. Mass cancels, the left out of formula lambda is H by E into T. T taken to the numerator becomes e to the power of minus 1. In terms of the T is not constant, time always changes, that is a variable. So lambda changes here. As the time t is coming to the denominator, as t increases, lambda decreases. The velocity lambda changes and wavelength lambda changes with the time. So rate of change of lambda with time is d, differentiation you take with respect to time, d lambda by dt. This becomes equal to differentiation of t to the power of minus 1 is minus 1, t to the power of minus 1 is minus 2. 10 to the power of minus 2 taken to the denominator becomes equal to t square. So d lambda by dt is minus h by e into t square. Negative sign here only indicates that decreasing. As the time increases, lambda is decreasing condition only it gives. Don't bother much of that. Next question, 12th one. D Broglie wavelength of the neutron, it is a V neutron. At a temperature 927 degrees centigrade is lambda 1. Find the wavelength at 27 degrees centigrade, what you have to find out. Neutron, lambda is given by the formula h by 2m into Boltzmann constant kb into t. Or lambda is inversely proportional to t. We require only this relationship for this kind of problems. For the uncharged particles, acceleration is done by changing the temperatures. So lambda is inversely proportional to root of t. Lambda 2 by lambda 1. New one is lambda 2, you have to find out. Lambda 1 is given as lambda 1, and lambda 2 by lambda 1 is inversely to the t, root of T1 by T2. But capital T is temperature in Kelvin scale, not in centigrade. But you are given centigrade converting to Kelvin scale by adding 273 degrees, 273 number. 927 degrees centigrade plus 273 becomes equal to the expression 1200 kelvins you will get. And 27 degrees centigrade converting into Kelvin plus 273 will give 300 kelvins. Substituting the value here, T1 is initial value is 1200 kelvins and new value is 300 kelvins. It becomes equal to root of 4. Root of 4 is nothing but equal to 2. That means lambda 2 is 2 times lambda 1. Next, 19th question is very important ones. A particle of mass m, it is very simple one, but actually concept related only, but very important ones. Particle of mass m decay into two particles, or a particle exploding into two parts at any number of parts. Particles of masses m1 and m2. Big particle is exploding into two particles, or decays in two particles, or nuclei decay into particles. Then non-zero velocities, they are moving with the non-zero velocities. Find the ratio of the de Broglie wavelengths of these two particles. What is the wavelength of the m1 and m2? But an explosion or a decay process, if the uranium is emitting the neutrons and other particles are the nuclear materials, disintegrate into daughter nucleus, emitting other particles, alpha particles and other particles. Now, in that cases, the initial momentum, if it is at rest, is 0. The final momentum is m1 v1. These particles having the m1, first particle mass m1, velocity is v1. Second particle mass is m2, velocity is v2. The momentum, total momentum before equal to total momentum after. Whatever momentum is there before will be the same for the afterwards. So afterward, two particles are there. So total momentum is m1 v1 plus m2 v2. But initial at rest means 0. If initially also particle is in motion means mu. You have to take u is the initial velocity. This m is the total mass. M equal to m1 plus m2. Whatever the particle masses here, they are moving here. So total initial at rest given here. So initial at rest not mentioned in that case also, you take it as a rest. Then m1 v1 take it to the other side. No, you will get m1 v1 is equals to minus of m2 v2. More mass, less velocity. Every particle with the less velocity, mass and velocity is constant. Negative sign indicates upper direction. One particle going to the left side means other particle goes in the upper directions. But momentums p1 will be equal to p2. Negative sign only upper directions. Momentums are equal, but you are asked to find the lambda de Broglie wavelength ratios. Lambda is equal to h by momentum p. P is same here for both, only upper direction is opposite. So lambda 1 by lambda 2 is equals to p2 by p1, which is equals to 1:1 we will have. p1 is equals to p2. Therefore, lambda 1 by lambda 2 is 1:1. This is an important problem. Please don't need to work out again. Whenever the particle explode into parts, the parts have the ratio of the momentums of these particles will be, because momentum as the particles are same, is equals to 1:1.